This video will look at composition of a trig function with the inverse of another trig function. We start by working with whatever is inside the parentheses. So remember, this question here is really asking for the angle whose sine value is 12 over 13. For our purposes, we're going to call that angle theta. Inverse sine is defined in quadrant 1 and quadrant 4. Since the value I'm looking at is positive, we must be in quadrant 1. Now normally we would start looking at ordered pairs, but 12 over 13 is not on the unit circle, right? So if your value is not on the unit circle, just draw a triangle. Now we'll put in the information that we know, we'll put in our theta, and we'll put in the 12 and 13 in the appropriate places, 12 the opposite side, 13 the hypotenuse, and then we'll use the Pythagorean theorem to find the missing side, which is the adjacent side. Now what we're really being asked is for the tangent of theta, and looking again at my triangle, tangent is opposite over adjacent, so the tangent of theta is 12 over 5. Here, again, we're going to look at the inverse sine part first. That is asking for the angle whose sine value is negative 2 over 5. And we're going to call that angle theta. Inverse sine is defined in quadrant 1 and quadrant 4. Since that value is negative, we must be in quadrant 4. Again, negative 2 over 5 is not on the unit circle, so if your value is not on the unit circle, we need to draw a triangle. Notice we drew this triangle in the fourth quadrant, that is important, and we'll put on our information, our theta, and then our negative 2 over 5 for opposite over hypotenuse, and then we'll use the Pythagorean theorem to find the missing side. Now, really what we're looking for is the secant of theta, which is 5 over root 21. One more like this, looking for the inverse tangent of negative 6, so we want the angle whose tangent value is negative 6, we'll call that theta. Inverse tangent is defined in quadrant 1 and quadrant 4. Since the value is negative, we must be in quadrant 4. Negative 6 is not a value on our unit circle, so we need to draw a triangle. We'll put our information on, negative 6 opposite, 1 adjacent. I know that the 6 is negative because of where it is in the fourth quadrant, right? That 1 couldn't be negative because that's on the positive x-axis. Next, using the Pythagorean theorem to find our missing side, it is the square root of 37. So the sine of theta is what we're really looking for, and the sine is negative 6 over root 37. So now for a different type. Here we will first work with the cosine of 4 pi over 3. 4 pi over 3, there's the ordered pair. So the cosine of 4 pi over 3 is negative 1/2. Now I will replace the cosine of 4 pi over 3 with its value of 1/2. So what I'm looking for now is the inverse sine of negative 1/2. Remember that question in English is what angle has a y coordinate of negative 1/2? Inverse sine is defined in quadrants 1 and 4. Since my value is negative, we're in quadrant 4. It's my family of over 6's that have the y coordinate of 1/2. And my pi over 6 in quadrant 4 is negative pi over 6. Remember that we cannot go through the third quadrant with an inverse, right? So if it's in the fourth quadrant, we just have the negative angle. Another one. First, I look at the sine of 7 pi over 6. 7 pi over 6, there's the ordered pair, so its sine is negative 1/2. Now I replace with my value, so what I'm really looking at is the inverse cosine of negative 1/2. This asks what angle has an x coordinate of negative 1/2. Inverse cosine is defined in quadrant 1 and quadrant 2. Since this value is negative, we must be talking about quadrant 2. It's my family of over 3's that have x coordinates of 1/2. And my over 3 in quadrant 2 is 4 pi over 3. Last one. We'll start by working with what's inside the parentheses, the tangent of 7 pi over 4. There's the ordered pair for 7 pi over 4. So the tangent of 7 pi over 4 is the y value over the x value, which is -1. Now I'll replace it. So now the question that I'm answering is the inverse sine of -1. That question is what angle has a y coordinate of -1. Inverse sine is defined in quadrants 1 and 4, but everything that has a 1 as a y coordinate is a quadrantal, right? So there are your quadrantals, pi over 2, pi, 3 pi over 2, and 2 pi, which you could also call 0. So the one that fits the bill that has a y coordinate of -1 is 3 pi over 2. So the inverse sine of -1 is going to be negative pi over 2. Remember, we can't say 3 pi over 2 because to get there we would have to go into the third quadrant, and we can't do that. All right, I hope you found this helpful. Have a great day.